with quality. Quality is a course you may take later in the program. It is a very large area and very important area within supply chain, business. So we'll go through some of the major points on quality. Our learning objectives is to define what is quality and total quality management, what is Six Sigma, how companies use benchmarking, and discuss some of the 7 tools of quality or total quality management. Now, there are many different definitions of quality, and in this particular case, what we're doing in our course is to identify that total quality management, or TQM, identifies and satisfies customer needs. So you're trying to satisfy what the customer wants. And as a note, students are not the customers for the school. Employers are. It is our responsibility to teach you the things not that the instructor or professor thinks is important or the school thinks is important, but future employers say they want you to have these skills. So, another definition of quality is the fact that it is a product or service that, again, satisfies the customer needs. And that comes directly, as you can see, from the American Association or Society for Quality. Some key dimensions of quality are features like performance, reliability, durability. Engineers like conformance. This is where you have tolerances, serviceability, even aesthetics, how it looks, how it tastes, smells, feels even. Think about some clothes that you bought. You know, you like the way it looks on you, or you like the way it feels, like, say, running shoes or something along that line. And does it provide value? And what's the perceived quality? So there are some costs of quality. There's 4 of them. Prevention is the least expensive. So preventing the problem, preventing the defect is the least expensive form. So if an instructor is preparing an exam and they find an error before it's been printed or posted online, that is the least expensive. So publishers spend a lot of work and a lot of money trying to make sure and vet the questions. So I have done a lot of work for McGraw-Hill and Pearson Education, going over problems and finding mistakes before the product gets published, because it's very expensive if a textbook has been printed and there's errors in it. It's much easier if it's a digital format because they can be updated instantly. But even then, there is a cost. I even do work for McGraw-Hill with regards to the fact if there's errors on a website or potential errors, say in a solution, they send it to me if it's a finance-related error, and I check it over to say, yes, that is an error, or no, it's not. Appraisal costs. This is inspecting things, looking things over. But if you haven't made the error in the first place, you don't need to do appraisal. Next, internal error is where you find it beforehand. So if we're getting a final exam ready for you students to write, all of the instructors that are responsible for that course are responsible for going over at least parts of the final exam to make sure the calculations are correct, check wording, things along that line. And we still make mistakes with simple things like, you know, it says it refers to parts A, B, and C, and then we label it 1, 2, and 3, stuff along that line. Or heaven forbid, there's some number error, things along that line that can happen for an exam, that happens for in many times in industry, but you've caught it before it goes out the door. So in this particular case, it gets fixed ahead of time. The most expensive by far is external errors, when basically your customer finds it. So this is where you start dealing with warranties, recalls, bad publicity, etc. Total quality management, as you can see, is just what the name indicates. It encompasses the entire organization or everybody, right from the first person that they interact with to the end. And it even involves your suppliers. So if there's defects in materials or flaws in materials that you're getting, that will affect your final goods. A very famous quality guru is Deming. Edward Deming is been has the Deming Institute and is considered to be a leader, or was when he was alive, in the quality area. I'm not going to go through each one of the 14 points, but I will highlight a couple of them. Point number 4, build long-term relationships based on performance instead of just price. So also think about this. If you have a close personal friend, there are things that you're going to do for that close personal friend that you would not do for somebody who's an acquaintance or somebody you just met. So like, person you met in kindergarten who's still your friend, there's things you would do for that person that you wouldn't do for somebody you just met last week. Kaizen, point number 5, continuous improvement. I'm a big proponent of this. I've promised myself as an instructor that I will always constantly be trying to improve the product or the quality that I'm delivering to the students. And the day that I run out of ideas to do better is the day that I've promised myself I will stop teaching. So I constantly want to get better. Point number 8, driving out fear might seem like a really basic idea, but if people are fearful with bringing out comments, so a student doesn't like the way an instructor is doing something, they're fearful if they say, Ms. or Mr. Instructor, I don't like the way this is going, because they're fearful that the instructor will take offense to that and punish them by, how you punish somebody, in your guys' case, giving them a poor mark. So, but you need an openness. You need to be able to say, well, this is not working well, and you need to be able to accept that too. So those are just a couple of the major points. This is just sort of for your reference. We're not going to specifically ask you to list like Deming's, give us 10 of Deming's 14 points. We just want you to understand that there are various principles, shall we say, with regards to quality. Continuous improvement, Kaizen, always getting better. At one point, the slogan for Lexus was the relentless pursuit of perfection. So never being satisfied, always trying to be better. And, you can do this with New Year's resolutions. You can say, well, what am I going to work on in this year? How am I going to try and make myself a better person? Six Sigma is a statistical process where you only have 3.4 defects per million opportunities. So it's a very high level of quality. It's considered 0 defects, even though there's 3.4 in a million. So think about this. If you have a million capacitors that you're going to populate a cell phone board with, and there's only like 3 or 4 defects in them, you just put them on the boards. You don't have to test it. It's too expensive to go through and find maybe those 3 or 4 defects. So you just put them on the cell phone boards. And 3 or 4 out of a million won't work. So it's the least expensive form of quality when you have that high level of quality or that low level of defects. So you can see that in the past, there was 3 Sigma, which means there was 2,700 defects per million. And with 6 Sigma, so 6 standard deviations to the left, 6 standard deviations to the right, you now only have 3.4. So it's not double the quality. It is about 99% improvement from 2,700 to about 3.4. So it's about a 99% improvement to quality or reduction in the amount of errors. Benchmarking. A lot of you do this whether you realize it or not. A lot of times students will say, what was the class average? For a couple of reasons. One is you want to see whether you were above or below the class average. Oh, well, I got a mark higher than the class average, means I'm better than average. Another approach that a student might have is, and I've had students tell me this, I don't care what the class average is. I just care what my mark is. So let's say you set your standard that you want to get an 80 in a particular course, and you get a 77. You are below your target, no matter what the class average is. And in this particular case, you can also exceed the class average by having like a 91. So, different ways to benchmark. I did have a student one time who had a 78 on their midterm exam. And to get an A, they needed an 85. They withdrew from the course because they knew that they'd have to get like 95 on the rest of the course to get their A. So they actually withdrew. Had a student in the exact same section one time who failed quiz 1, the midterm, and quiz 2, but like 45%, so it wasn't like a dramatic fail. Stayed in the course, worked very hard, got like a 61 or 63 on the final exam, got a 54, 55 for the course, and stayed in the course. So you have one student who's got like a B plus who withdraws. You get a student who's literally got an F who stays in the course because they were looking at their own benchmark. One student just wanted to pass the course, didn't care whether they got an A, B, C, or D. Well, they did, but they just wanted to pass. So they stayed in based on their benchmark. Some of the tools of quality, check sheets, which we'll see in a moment, some scatter diagrams, cause and effect, also called a fishbone diagram. So these are some of the tools that you might have to apply on an exam where you are given a set of data. And we're not going to ask you to list the 7 tools of quality. We're not going to ask you to list Deming's points. We're going to ask you to, here's a problem, how would you solve it? So some of you might use a check sheet, some a cause and effect diagram, etc. So here's what a check sheet looks like. It's tick boxes. So in this case, you have A, B, and C defects, and you simply make a little tick or line. You can use check marks if you want, whatever, and identify the defects, in this case, in an 8-hour shift, and the types of defects. Scatter diagram. You can see, you've seen many of these over the years. In this particular case, it's downward sloping as far as the absenteeism and productivity. Of course, the higher the absenteeism, the lower the productivity. Cause and effect diagram, and you should look at the 4M model. What you do is the effect. So let's say you do poorly on an exam. Well, maybe you didn't have the right machinery or equipment. You didn't have the right calculator, say for a statistics exam, etc. Or in our case, you don't have Excel or you don't have access to technology. That's why you might do poorly on something. Manpower would be yourself, say the instructor. Materials, again, I don't have a computer. That would be equipment or machinery, but I don't have a pen and paper, etc. And then the methods would be the way of doing things. So I did it manually, or I did it using a calculator when I could use a computer for doing it. So the methodology is different. So Pareto chart simply is a graph that goes, it looks like a set of stairs where you start off with the highest defect on the left and then go down to the right. Flow chart identifies like the steps in the process. So you can see the frequency diagram for a Pareto chart. You start off on the left with A is the most frequent defect, and then it goes down to E. So it's it looks like a set of stairs going down. The dotted line above is called a ogive. What that does is show you the percentage. So you have A, whatever percentage of defects, then you add B, that becomes the second dot, and then all the way up to 100% defects, or what is 100% of the defects. Flowchart, you have various decisions. Is the defect loading the paper? Is it the into the printer, etc. So are the checks not getting signed properly? It's, are they not aligned? Because a lot of them are mechanically signed these days. So, or why are we sending payments out to the wrong vendors, etc. So you find out where or what steps in the process are causing the defect. A lot of them times it'll be the same step. Just like you in your courses, there'll be a certain step that causes most of the error. And in my experience as a instructor, step number one, students misreading the question is by far and away the biggest cause for lost marks. Histogram looks like a normal distribution. Statistical process control, we really don't take in this particular course, so you can leave that for your quality course. So you can see that in a histogram, the frequency diagram, it looks like a normal distribution. Statistical process control, you have target values, upper and lower control limits. Are they in control, out of control? But again, you'll leave that for your quality course should you take a course in quality. So that one you can kind of skip. Fishbone diagram, you can see here there's the 4 M's for a missed free throw, all kinds of potential problems with it, from the air pressure of the ball, the size of the ball, are you shooting properly, are you bending your knees, the position of your hands on the ball, down to the machine, the rim alignment, the rim size, the rim height, things along that line. And manpower, the conditioning of the shooter, the motivation, the training that they put into, etc. Flowcharts, you can see, I'll let you read this. It's just, where are the defects occurring? Are they occurring in step number 5, where the technician carries out the MRI? And then you have to look at, is the technician properly trained? Is the MRI machine itself has a problem? Is a machine old? Is it calibrated properly? On and on and on. Again, we'll skip statistical process control. You can take that in a future course. So here's the charts. Service quality, you're talking about reliability. You're talking about responsiveness, how quickly somebody provides a response. I've taught for an online school, and their standard was 48 hours. You must respond to all students' emails within 48 hours. And an instructor had to be online at least every 48 hours. Competence you take for granted. Does the person have the right skills to be able to perform the service? Something you assume, but hopefully is the case. Communication, keeping customers informed. Credibility, is it trustworthy? Do you go to an accredited school? Courtesy, which is simply politeness and respect. And you people realize you can get a long way in life with courtesy and respect and being polite, and especially in today's politically correct world. And intangibles, including the physical service itself, like and that's the end of the chapter on quality. I hope you've enjoyed it. We'll move on to some examples.